How crucial is it to understand the presence of microplastics in water? The answer might be more significant than one might initially think. Microplastics, tiny fragments of plastic less than 5 millimeters in length, have infiltrated every corner of our ecosystem, including the water we drink. To comprehend the extent of this issue, it becomes essential to learn how to detect these nearly invisible invaders. The first step in this detection process involves collecting a sample of water. Whether it's from a tap, a bottle, or a local stream, the source doesn't matter. What's important is that the sample is representative of the water typically consumed or used. The next stage is all about filtration. The water sample is filtered using a filter with a pore size of 0.45 micrometers. This specific pore size is designed to capture the tiny microplastics present in the water. It's like casting a net to catch fish, except, in this case, the fish are microscopic plastic particles. Once the filtration process is completed, it's time to move on to staining. The filtered microplastics are stained with a dye known as Nile Red. This dye is lipophilic, meaning it has an affinity for fats and is therefore able to penetrate and stain plastic particles. The staining process helps to make the invisible visible, bringing the microplastics out of hiding. Following the staining, it's time for observation. The stained microplastics are observed under a fluorescence microscope. Under this microscope, the microplastics fluoresce or glow, making them easier to see and count. The final stage is quantification. The fluorescing microplastics are counted to quantify the amount of microplastics in the water sample. This step provides a clear picture of the extent of microplastic contamination. However, it's essential to keep in mind that this is a simplified version of the procedure. Actual laboratory methods may involve more steps and precautions. This method also requires specialized equipment like a fluorescence microscope and specific chemicals like Nile Red dye, which may not be readily available at home. Safety should always be the top priority when conducting any experiment. For a more in-depth investigation, other detection methods such as Raman spectroscopy or Fourier transform infrared spectroscopy should be considered. These methods require more advanced equipment and expertise, but can provide more detailed information about the microplastics, such as their chemical composition. In summary, understanding the presence of microplastics in water is of great importance. It starts with collecting a water sample, followed by filtration, staining, observation, and quantification. Each step plays a critical role in detecting and understanding the extent of microplastic contamination. Remember, knowledge is power, and in this case, it's the power to protect our water and our health from unseen threats.